So we'll just keep going through the introduction as we let other people into the webinar. So the outline of this discussion is we'll just talk a bit about Accrete, what we do. Then we dive into the topic of the day, which is the digitalization move by the industry, the benefits, and we look at the case study of an actual deployment, that we have been involved in. Then we take your questions. So just a bit of safety notes, especially with respect to Nigeria. So encourage everyone to be safe out there, because of the rising case of insecurity in the country. So about Accrete, is a petroleum engineering service company, and our services are majorly in the areas of software deployment, field management software deployment, consultancy, and training. So the software deployment is in the area of integrated production modeling, digital oil field deployment, which is the topic of the day, and hydrocarbon accounting tool. So our partners in this service area are petroleum experts for the integrated production modeling and digital oil field, and Adept Solutions for the hydrocarbon accounting. So our hydrocarbon accounting suite of tool is called Axis, so it's used worldwide. Then we have our consultancy services on integrated production or asset modeling and production optimization type studies, digital oil field deployments, and all the other ancillary services to the digital oil field realization. So we also offer training services and field services. So in terms of the topic of the day, which is the digital transformation of the industry or the digital field of moving oil and gas field management to the real-time domain. So for the past couple of decades, there's been a lot of significant move towards digitizing the operations of the industry. And this has been driven primarily by the bid to look for more efficient ways of operating our assets, driving down costs, improving efficiency. And one of the major drivers in recent years for this, for companies looking for ways to digitize their operation and automate a lot of their tasks, is the recent low oil prices, right? And these have driven companies to adopt several technologies that help in reducing the cost of operations and improving the efficiency of operations. So apart from just digitizing or moving operations to the real-time domain and automating a lot of workflows, the vision is pretty much to have a connected enterprise. So on the one hand, you have sensors on the field that you can use to feel the pulse of your operations. But on the other hand, there needs to be a way of actually integrating these platforms that bring the operations to the real-time domain with other aspects of the value chain. Just so that there's this global picture and bird's eye view of the operation of any firm, where any issue on the field, the impact on other aspects of the business can be viewed on one platform. So pretty much optimizing the end-to-end value chain of a business. So like I said, mentioned earlier, the common drivers for the move towards digital solutions in the oil industry have been one, cost savings, right? And one of the key drivers for this drive towards operational cost savings have been, low oil prices in recent years, and in a bid to reduce the cost of carrying out these operations, then automation actually is one of the key drivers and one of the key tools that the industry is adopting in reducing the cost of operations, right? So other added benefits of that would be having all the information you need to make decisions available to you in an instant or in real time and in the right context. Then production optimization, which is also one key aspect of this discussions today, is another key aspect or another key driver towards the digital transformation of many E&P businesses. Then you also have the benefits of being able to reduce compartmentalized behavior that is inherent in that it's typical with oil companies, where you have several disciplines working in their own silos. So once you have a platform where everyone can have the same source of the truth of the operations, then it reduces this tendency of different personnel in different parts of the business to work in silos. And this actually improves the efficiency of the operations, because one, the back and forth and the iteration that you typically have in going from one department of the business to the other in getting information is eliminated once you have a platform that everyone can collaborate, and the same set of data, the same set of the truth is presented to everyone. And there is also the operational risk and accident reduction, right? Because if you don't have to commute to isolated distance facilities to acquire data, then the cost associated with that is reduced dramatically. The risk associated with acquiring those data also reduces dramatically, right? Because you don't have people being exposed to the typical high pressures that are related to operating oil and gas fields. So down to the core of the discussion, which is pretty much digital oil field. So the question is, what do we understand by digital oil field? Because the term is used a lot in the industry, it's thrown around a lot, and there are several meanings. Different people have different meanings of what digital oil field is about. Different vendors have different presentation of what digital oil field is. But what we'll do now is, okay, just to sample ideas, we would try and send out a poll that should come up on your device. And if you can just type one or two words, a couple of words on what you understand by digital oil field, then we'll just give you a few seconds, say 10 seconds. We send out the poll, then type what you understand by digital oil field. Then we can just take the discussion from there on our own understanding and presentation of the digital oil field. So if you can just type and submit the responses, what's your own understanding? If you can be a word, it can be 2 words or a few words of what you understand by digital oil field. If you can see the poll on your device, just type a few words and let's see. Okay, digital twin, representation of a field, real time, digitization, automation. Yeah, so I mean, like a virtual representation, yeah. So, and from here as well, if you hover on this word, you can see the number of times each word appears in different people's definitions. So you can see that automation is actually a lot. It's coming up a lot in people's responses of what digital life means, right? And all these definitions are not, none of this definition is wrong, right? It's just that from our own perspective, the digital oil field could actually be all of this in one, right? So, if a digital oil field is all of this in one, it means that we have a way of one that is really interesting to me is digital twin here, right? Or digital representation of a field. So we'll now go on to what our own understanding or presentation or definition of a digital oil field is, which is pretty much like many people have mentioned here, should be a digital twin of your field or a digital representation of your field, right? If you can have a digital representation of your field on a computer, then it means that you can test out ideas, on that digital replica. One, it's good for surveillance. Whatever is happening on the actual field, because we have sensors on the field that are pretty much telling us what's happening on the field, right? So whatever is happening on the field, we can see it in the digital replica of the field that we have on the computer, right? So 2, we can test out ideas on how to make things better on the virtual replica of the field before going ahead to implement them on the field. And we can also look at automating certain workflows, say production optimization workflow or a flow assurance workflow. So all this can be automated or tested out on the virtual replica of the field before going ahead to implement them on the real field. So if we have that replica, we already tested out to see the performance on the virtual replica of the field, then we go ahead and test it out on the actual field itself, right? So a way of having that real world in a virtual sense, and this comes from being able to for this example here, we have the field on the left, and sensors at different parts for different points in the system. You can create a virtual replica of the field, which you can use to test out different ideas before we implement them on the field. So that way, at any point in time, we can achieve measurable improvements, and we can test out those improvements in the virtual world before taking them to the real world. We can anticipate issues before they happen at all. It means that we have a proactive approach to managing the field performance. So I've outlined a few of the typical benefits that are available out there. These are publicly available information in terms of these key drivers that we mentioned some of earlier, and a significant part of it is one, cost saving. And there are some figures here from Shell. I think there's an SP paper available on this about Shell in terms of the value of smart fields over a 5-year period. I think this paper was written in 2010, and the estimate then was about $5 billion over a 5-year period. There's this study by IHS about the operational cost savings and all. So with these potential savings in automating the operations of the field, so companies are really driving towards transforming their operations and digitalizing them. Then there are other benefits that come with it as well: safety, improved operational efficiency, data being made available to decision makers in the right context in real time. So it means that at any point in time, we can be able to make quick, sound feed management decisions, and that brings a tremendous value. So in terms of like based on our definition earlier, there are several different technology components that come together to that makes up an ideal digital oil field from our perspective. So for you to be able to replicate the performance of your field, it goes beyond just having sensors on the field, right? Which is the instrumentation side of it. We should be able to have a physical model of the field or a simulation of the integrated field performance, with which we can integrate this data coming from the field. And we can now, on top of that, build workflows that replicate how we want the fields to be managed in an optimal manner, right? So in terms of the technology components, there is the IT side of it, which in many cases, many companies already have, or if a company, the IT infrastructure is outsourced, there are cloud systems that can be used for that. Then there is the field instrumentation, right, where we have all the real-time data acquisition comes into play. So you have sensors on the field, the wellheads, at the flow lines, at the separators, and these sensors are sending data into the your database, your real-time historians in real time, and we now have workflows that we can use to automate certain objectives that we want to achieve in real time, right? Then on top of that, we need a platform where we can see the results of these workflows, right? Where we have analytics of all the tons of data coming into the system, and we also have we can also collaborate with other people, other members of the team. So these 4 major components, generically speaking, should be available for you to be able to achieve an ideal digital oil field system. So with that, then we have a system with which we can pretty much mimic what is happening in the actual asset. So this diverse technology component needs to be rationalized, need to be put in a context that makes them usable by the companies, the end user. So, well, this is publicly available. It's based on it's from an SPE paper that you can access. And in terms of a generic infrastructure of what a digital oil field, how to rationalize these diverse technology components that makes up a digital oil field system, then we should have a layer for the data and the models of the field, right? So the real-time data coming in, the integrated model of the field. Then we have workflows with which we can use to automate certain field management and business processes. It can be a workflow for well surveillance. It can be a workflow for production optimization, workflow for well test analysis, or workflow for other business process that we want to automate. Then we have a layer for collaboration, which should be a visualization layer. So the vast majority of the users that interact with the system would interact through the visualization portal, right? So, and with that, you can carry out the results of your workflows, the results of the analytics, the optimization advisory, and all that can be seen on that visualization layer. So, that being said, this is a generic workflow in terms of how to rationalize all the many different technologies that come together to make a robust digital output system. So in terms of Accrete and our partners, we actually also have, we offer this digital output system in a similar manner, which based on what you see in the literature, that's pretty much the best practice in implementing robust DOF systems. So we offer this end-to-end solution, from the real-time data, which is the field instrumentation, all the way to workflow and business process automation and visualization, right? So we have the integrated model of the field itself, with which you bring in real-time data to now kind of mimic the real-time performance of the system. So this is another presentation of how this is this digital output system is delivered in the context of the different components that make up the system. We have the data on this on the left side, your production data, your well test data. Let's say you have a hydrocarbon accounting platform, then your real-time data. This is where the gauges and sensors on the field come into play. So integrating this data from diverse sources with different time frames, with physical models of the field, engineering workflows, and visualization pretty much forms the DOF system that allows you to achieve all these objectives in real time. Virtual metering, production optimization, surveillance, and all that. As you can see, the products in the middle here are Petroleum Experts products, and Petroleum Expert, like I mentioned in the beginning, are our partners. So the case study that I'll go through will show how we actually have brought all these different components together to deliver a digital oil field system with which all these objectives are being achieved, right? The well test management and production data management system, coincidentally, we also have a partner, Adept Solutions, that offer this high axis hydrocarbon accounting system that is integrated with the ETEX suite of tools to provide the production and well test data to the platform. So this tool is agnostic to third-party software and platforms. So it pretty much means that energy components or OFM, any data you use, any system you use for managing your production system, your production data can be integrated here. So in the case of the real-time data, a real-time historian, OCSOFT is being used for the system we'll look at shortly. So in a nutshell, I'll just go through the components again in terms of the data, the models, the workflow, and the visualization before going into the case study. So in terms of the instrumentation, so we offer this service where the gauges are retrofitted to any asset, and the gauges are wireless, they are battery operated, and they can the batteries can last for up to 10 years with quite high frequency of data transmission. And the data is transmitted wirelessly to your on-premise historian, right? So with this alone, with the real-time data alone, there's a lot you can already achieve. That's even before you integrate them with the model of the field that simulates the actual performance of the field. So an example is we have those gauges installed on the field. This is actually a screenshot from an actual system. And you can see that in real time, you can see the pressures and temperatures coming from the field in terms of the wellhead pressure, flow line pressures, manifold pressures. And you can trend those pressures, just the real-time data alone, you can trend them and they give you an insight into the performance of the well. The signature of these pressures, real-time data coming from the field, can tell you if a well is shutting, if a well is flowing, if there are, if there are data points that are require your attention, right? And we can now build workflows on top of this real-time data and models of the well to be able to, have much more insight into the performance of the system. So that's the first component of the DOF system. The second component is an integrated model of the field. And for this integrated model, this is an example of a gap model, which is a petroleum expert using petroleum expert suite of tools, Crossfire, MBAL, and gap. So I know it might be quite small. We'll take questions by 12. Once we are done, so we'll just take note of the questions and we go through them by 12. So you have the reservoirs, you have the wells, you have the chokes, you have the flow lines, then you have the manifolds where the fluids are gathered, then you have the separators, and with the real-time data coming in, this system can be solved repeatedly every 30 minutes, and it gives you the current production rate of each well, the current pressure distribution across the network, and all that, as we shall see in the case study shortly. So these are, the workflows that are available for the business process and automation of the field, the field management tasks. So these are actually workflows from the Petroleum Expert suite of integrated field management tool. You can see that out of the box, there are over 100 workflows that are addressing different aspects of the system. And these workflows, we integrate them with the integrated model of the field and real-time data. Then there's a platform visualization with which the results can be viewed. So you have workflows talking about field surveillance, well surveillance, well production estimation, well test maintenance, ESP, and all that. So then all that, once the system is deployed, the real-time data, the integrated production model, the workflows all now work in the background at the back end of the system, and you have the results, on a platform, with different dashboards and different analytics that, depending on the role of the user, they can take advantage of. Right? For a manager, it can just be the high-level field performance that you want to look at. Oh, okay, what's the production? Are we on plateau? Yeah. Okay, so there is a dip here. So what's the cause of the dip? This plot can also be annotated to tell you what, there is obviously an incident here that caused this dip. Okay, then it was later restored to a stable production, but less than what the previous, say, 10 days was. So you had this 10 days of dip. So you have a platform with which you can, at the top level of it, the managers can ask different kind of questions. Then if you're an engineer, you can drill deeper and say, oh, I'm interested in well surveillance, takes you to the well surveillance section. I'm interested in a network surveillance, which is the system quality control, or I'm interested in optimization. So you don't have to spend 3 months gathering data, building models, before you can achieve these objectives. So you can pretty much click a button and these objectives can be achieved in 5 minutes or 1 hour rather than 3 months or 6 months, right? Because you already have a model in place. You already have, you have real-time data coming and these models are being updated on the fly with all these workflows. So you can focus on basically achieving objectives, business and engineering objectives, rather than data management or acquiring data and building models. So in a nutshell, this the digital oil field offering from Accrete and our partners, combines your real-time data, integrated production models, and workflows, and for automating different tasks depending on what you are interested in, and also a visualization and analytics platform, for day-to-day feed management and decision making. So it pretty much gives you an online real-time feed management system that everybody in the organization can take advantage of. So what we'll just do now is, in terms of maybe the PetEx system, there are a few case studies of companies that have implemented it and they have written technical papers on it. And these are, RasGas, BG before it became part of Shell, Woodside, Saudi Aramco, KOC. So all these papers, the references are there, they are available, and they can be accessed. So what we'll do now is spend the rest of the time, 20 minutes that we have left for the presentation, to go through a case study and see how there was an objective and how we were able to bring all these different components that makes up a digital oil field together to achieve the objectives, right? So this is a case in Nigeria and a gas condensate field. And there are several objectives, but once we looked at all the objectives, they fit into two major categories. And these are surveillance and optimization. So you see objectives like real-time field management, workflow automation, facilitate problem solving and decision making, surveillance by exception, real-time well performance monitoring, and all that. So, but in terms of the high-level objective, it fits into two major objectives, which is optimization from our perspective and surveillance. So now, in terms of the architecture for achieving these objectives and bringing this system into the real-time domain, and one point I would like to make is that prior to this, there was really no model for the field at that point. There was no integrated model for the field. So there were, a few well models here and there, a few reservoir models here and there, but there was no model that actually captured the entire field performance. So this was a first. So the deployment architecture was such that, we, collated all the data, then the real-time data, and built a model for the field, which is the IPM model, then deployed engineering workflows and a visualization platform with which all these objectives could be achieved. And once again, the IPM, IFM, and IVM, and products of petroleum experts. So the starting point in terms of, okay, there was no model for this field. So how do we get this field from not having a model to, being able to achieve objectives in real time? So the very first thing is to build an integrated model for the field, which is, there are several names. The integrated production model goes by several names, IPSM, IPM, IAM. But it's pretty much a model that integrates the reservoir performance with the wells and the flow line network or the surface facilities. So we see that, we have that integrated model built. So at this point, the model is offline. But even as the model was offline, we're able to achieve all these objectives. Choke size optimization, routing optimization, generated optimum well operating envelope and all that. So what you can see at the bottom of the screen is some of these objectives. So for each of the wells, an operating envelope like this was developed. So you have the lower bound, which has to do with stability criteria, right? So we use multiple criteria for the stability. So you have a toner, VLP, and a few other criteria that can be built. So if a flow is below that, then the well is likely to be unstable and load fluid for condensate. Then we have the high bound, erosional velocities, drawdown limits for each well in the field. Then we can see that this well sits pretty much within a safe operating range. But what this tells us is that within this safe operating range, we can pretty much produce and choke the well up to this point without having any issues. For having that in mind, there was also an optimization workflow which tells you that, okay, you cannot just open up the well to this point. So it has to be done following a specific workflow, which was developed as part of this initial integrated asset modeling. Then there was this opportunity ranking activity where we looked at opportunity for each string, use the model to quantify the opportunities, then rank them in terms of the cost, the risk, and the difficulty, right? So with that, we came up with this matrix with which, this optimization workflow can now be used to implement. So that was stage one of achieving this digital airfield system. Then stage two was to install gauges, right, on the wells and the manifolds and the vessels. So these gauges were installed. So what you can see here is that wireless gauges, and these gauges send data wirelessly to the real-time historian. So in this case, the OCSoftPy system is being used as the historian. So you can see the different installation points for wellhead pressure, flow line pressure, casing head pressure. Then we had installations at the manifolds and installation at the vessels. The gauges they blend into the system. They pretty much look like any other installation. So they don't stand out and attract so much attention because some of these areas could be quite prone to vandalization. So with those gauges installed, the data could actually be trended, like I showed earlier, and the trending of the data alone, without doing anything further, can actually give you already some insight into the performance of the system, and right, and bring tremendous value in terms of surveillance. So with that done, so the next stage was now to integrate the model of the field, which is the gap model of the field, with the real-time data system and all the workflows needed to achieve the objective. So what you can see here is what I showed earlier is an overview screen, a platform for collaboration, platform engineering platform, a portal into the system. And what you see at a glance is, for the last 1 month, what has been the production performance of the system? Then for the different flow station, what's the production like? So if there's a dip in production, we can pretty much see where that dip is coming from, right? At a glance, without having to call 100 people to ask questions. So then we can now ask specific questions. What happened to the wells in this field or flow station, right? Then we can see the wells are flowing. We can see the wells that are shutting. And what we can also see is their relative their production rates, right? So from here, we can dive into different aspects of the system. And we want to look at well surveillance, system quality control, optimization. This is another overview at the bottom here, where you can see wells located, the geographical location of the wells, and bubble map actually showing the relative production of each well. Then you can see daily average production performance of the wells. So this is like in the picture from the client's office, showing the system, on an interactive screen, and the users can actually just come to this screen, click on the screen, and be able to drill deep into any aspects of the system they are interested in. right? So apart from this overview, there are a few other screens. Let's say a manager would probably not go beyond this screen. Oh, I want to know out of 26 strings for this case, there are 12 flowing. Why are the other 14 not flowing? Why do I have this dip here? How can we get more? So, that can be the limit of the manager, for instance. Or an engineer wants to know the performance of each well in the system, right? And you can look at the well and look at the KPI of the well. How good is the KPI of the well? If the KPI of the well is not good enough, then you can say, okay, I have 26 wells, but these 2 wells, the KPIs are just average. So I can drill down and see what is happening to the well. Do I need to carry out a well test? Do I need to, is there an issue happening with the PI of the well or the pressure declining, right? So at a glance on the well screen, you can see the virtual metering part of the system. So the well rate estimation. So in this case, the source of this rate is from the VLP-IPR calculation, right? So you can have other choke calculation can be there, IPR calculation, VLP calculation. If it's a gas lifted well, there are other methods available for calculating the rates. Then because we have the PVT report of the well, an EOS model is built for the well into the system, then we have like flags here that tells us, oh, is there a wax or hydrate or scale possibility of that forming? Then we have other well performance screens available. Choke performance, wellhead performance, like, this performance is the plot of wellhead versus rate. Then VLP, IPR, then, model analytics, other analytics that goes into much more detail of the real-time data and the insight that can be gained from it. Then the well test data, the entire well test history can be viewed within the system. So like I mentioned earlier, the system is integrated with the hydrocarbon accounting system. So if the well test data comes into the hydrocarbon accounting system, then it's picked up automatically by the digital oil field system. Then the rates are converted to standard conditions. Then the user can decide to accept or not, because the system can actually notify you if this rate, if the well test data is valid based on certain criteria that built into the workflow or not. Then you can review it further and either accept, or not. Then you still have other visualization screen in terms of trending, all these real-time pressures coming from the system. Any pressure, any data you see coming into the system can be trended for the entire history of the well, right? So then we have production optimization advisory in the system. So because we have the gap model underlying the system, people that are familiar with gap, you know that you can solve the gap network by choosing an optimizer. So let's say, optimize with all constraints or optimize with potential constraints. So because the gap model is at the back of the system, and we have real-time pressures for the separator coming in, we have also real-time wellhead pressure and flow line pressure. The gap system can be solved at designated times, let's say every hour or every 30 minutes. And it can tell you, oh, based on the wells that are online now, based on the routing of the wells, you can get this more oil right now. You can get this more gas right now. You can get this more oil right now. And the good thing about the optimizer is it penalizes water production. So it means that even with more oil and gas production, you are getting less water, right? So if the routing of the well change, the optimization calculated will change. If more wells come on stream, the optimization, the optimum point changes. So this is pretty much the real-time production optimization feature of the system. And this is because we have a simulator, a replica of the field at the back of the system, solving, at designated times. So apart from just telling you that you can get more, it actually tells you how to get more. In this case, what the system is doing is choke size optimization, right? And it's telling us, oh, for you to get optimum, this is the choke sizes that you should adopt, right? And if you look closely, you see that in some cases, it's actually telling us to choke back some wells because those wells, their pressures are so high that they are actually backing out some other wells. So in order to optimize the production, it's telling us to choke back. So it's not in all cases that it actually tells us to open up the wells. So the system is that smart. So then there's the well test management feature, right? If your test separators, because the wells are instrumented at the surface, you have the wellhead pressure, the flow line pressure coming in. If the test separator is also instrumented, then you can see the rates in real time on the system as well. So it means that as the test is being conducted on the field, you can actually open up the platform and you can monitor the test that is being conducted. You can trend it. And once you have a stable trend, right, you can pretty much acquire a set of test data. So before the test is done manually on the field and the results are collated and all that, you already have a record of the test data, all because you have the real time, the instrumentation is there and the platform is there for you to now capture this test data and just start the analysis right away and start using it for as input into other analysis. Then the system also gives you, like I mentioned earlier, a facility to store the test data. So all the historical well test data in the hydrocarbon accounting tool or any database that you're using for well test can be pulled directly on the platform. Then you can see, oh, what's the last valid test? And what's the latest test? What's the test date? Then you can generate a report of the test history, right? So apart from that, the rest of the slides I have here are just pretty much showing different views available. So this is showing pressure distribution across the network, right? So we have the model, which is a gap model calculating the pressure distribution. We also have real-time data. So we can compare what the model is calculating with the real-time data. So at any point in time, it tells us, one, it gives us the validity of the model. Does the model need to be reviewed and recalibrated? Is the model still giving us the right kind of data? So if the model is still valid in terms of matching what is coming real time across the network, then it gives us more confidence in the virtual metering happening, virtual metering results, optimization results, and other objectives that we've built into the system. Then we have real-time flow assurance calculation happening here. Well, steady-state flow assurance, for each pipeline in the system, the pressure drop across the pipe, the temperature drop is calculated. Then we have a whole host of flow assurance flags and calculation available. Is it below or above erosional velocity? Are there risk of hydrates or wax? Is the pipe bottlenecked based on the pressure drop? Is the flow stable within the pipe? So you have for each pipe, because we have this model calculating in real time, we have real-time data coming into the system, then all this calculation can be done on the fly, right? So this is pretty much, what an ideal digital oil field system should be able to do, right? It should be able to tell you, you should be able to use it to interrogate the system and also, give you insight into the performance of the system. So this is also, also giving us the capacity overview of the system. So if we're trying to reroute wells, the system can give us a snapshot of where we have additional capacity available in the system, just so that before rerouting wells, we have that understanding, right? Okay, so we'll be rounding up shortly, just so that we are within our planned time. But before that, we'll just ask a couple of questions, right? Just so that, let's just test our what we've been discussing so far. So we'll just send two questions across. Just so you know, the first one is in terms of automating repetitive tasks or field management tasks, right? So you can just click on is a multi-choice question. So just click on the answer. So companies can automate mundane tasks using, which aspect of the DOP system can we use to automate tasks? So we can just, pick whatever answer you feel is correct. And okay, yeah, so workflows can be used to automate repetitive tasks that we have, that we typically do. So the last question that we have is, what is an industry issue addressed by digital oil field? The whole digital transformation that we've been talking about, what industry issue? So once you click on an answer, and you'll be able to see the result from everyone. Right? So what is an industry issue addressed by digitalization or digital oil field? Workflow automation, data democratization, collaboration. So with a few more responses, then we can go to addressing questions. Okay, yeah, I think that's correct. That's pretty much right. So everyone chose all of the above. Workflow automation, yeah. Data democratization, yeah, because data is made available to everyone in the right context that they need to work with the system. Then, the visualization feature of the robust digital IP system allows different people with diverse skill sets to be able to have a platform for collaboration in real time. Right. So thank you all for all the responses. It's been a good one. So what we'll do now is we've pretty much covered all the content we have for digital oil field. What we'll do is maybe before the questions, I can once again reiterate what a digital oil field system is, right? It should be a system that should be able to replicate the performance of the field on a computer, more or less like a digital twin of the field, with which we can do things and control things in the virtual world before taking it to the real-time domain. Then what are the technology components that come together to make a digital oil field system? Field instrumentation, workflow automation, and a collaboration platform or visualization platform. Then what is a typical DOF architecture? We should have a way of modeling the system, and a system for managing the data, a system for managing the workflows, and also we should have a platform for collaboration and visualization. So then we talked about Accrete offering, and in terms of all these components needed to deliver a robust digital oil field system, we offer all the services, in collaboration with our partners. So field instrumentation for the real-time data, integrated asset model or integrated production model or IPSM, right? So this is, bread and butter of what we do. Then workflows to automate your field activities and business processes. Then a platform for visualization, right? And collaboration. So with that, we can pretty much start looking at taking questions. Okay, you can use the raise hand functions available if you have a question, or if you want to make a comment. We're taking questions and comments or recommendation. We pretty much have 30 minutes between now and 12:30 to do that. So you can either raise hand or you can type the question. You can raise your hand or you can type the question. Okay, we have Emuche Daniel. Yeah. Okay, go ahead, Daniel. You can unmute yourself now.
Okay, yeah, thank you. Yeah, my question is this: if I have this installation on my well and it goes bad, is there an email or how will I know that it's bad? Let's say with time after a year or two, and this device is bad in the well, and nobody knows, and there's a lag, there's a 2 or 3 hours lag, or 2 or 3 hours before someone notices that this stuff is not working. What happens within those data, that time, those real-time data within that period? Will I be able to see it, or what happens in that case?
Okay, yeah, I mean, so that's where the workflows come in, right? So because like we said, there are two aspects of workflows that we have in the system. One aspect is engineering workflows that use the models, your Prosper, Embal, and Gap models for the field. Then we have data-driven workflows. So the data-driven workflows, we can set thresholds, right? And the thresholds actually, if obviously there are reasons for it going to zero, for instance, for certain gauges reading zero or reading a very low value. And we can set those thresholds that it either shows as a flag on the system, right? It either shows as a flag on the system, or it actually probably prompts you, because the system is, is an open platform. So the threshold could be that, oh, if there is a flag, send an email to a designated person, right? So there are multiple options available for that. Then what you also have is there are reports that we typically also generate that are specifically for the real-time data. So this report, you can generate it, and what it does is there are reports that tell you for the last 3 days, is there any gauge that has now received data, right? So then it highlights them. Or is there any gauge? Because there are instances where there are some errors where the gauges keep repeating the same data, right?
Yeah.
Because for a real system, the data should it should be like a pulse. It should change a bit. So if it's now repeating the same data over a few days, the report will actually show you that, oh, this gauge or these few gauges have been repeating the same data for the last 3 days, right? So there are multiple ways of actually knowing that there are issues. Then one other thing is the rates being calculated are based on real-time data, right? So if there is an issue, let's say this goes to zero, then the choke method being used for calculation will start reporting zero, for instance. Then the VLPIPR will be reporting values that if you've set a threshold, the value would also be reported as an error, because if it's zero, then it's pretty much atmospheric, right? For this well that is producing 450, producing about oil rate of 673 for 450 psi now. So if it goes to zero, then it's going to be producing a whole lot more than that, right? And if you already set, the workflows will be built such that there are thresholds that it would have to report. So, and the report can either be visually as a flag on the platform, or it can be by email or text message or any option that you opt for.
Okay, thank you. So my second question is this: you mentioned that these things are Pi server based, right? So if a company decides to change their server from Pi to something else, what happens? Do you have to calibrate these devices, or you have to get new ones?
No, because we have the devices, then we have the network and the backend software that the devices use, right? So,
Yeah,
and this backend software, they typically have like a standardized interface for communicating with different systems, right?
sure.
So it means that if I change from one system to the other, I'm not going to change the device. I'm just going to, reintegrate it with another interface that the new historian or database or cloud system is using. So, most device manufacturers, make them, or network creators, always make sure they implement one or two standardized interfaces, that can be used for data communication with different systems.
Thank
Yeah.
you very much.
Thank you. So there are a few. Okay, we'll send as maybe the questions are going. We'll send a feedback form. It should take you, say, 30 seconds to just click a few buttons and write down a few things. Please if it comes up on your screen, please fill it so that we can have your feedback and your recommendations. But for now, I'll answer a few questions here. Will the presentation material be shared after? Yeah, from Michael Limbong. Yes. Okay, it has been answered. Yeah, it's real. Then I think a few of the questions have been answered. As a real-time data capture. Yeah, of course. I mean, flow rates. If your meters are instrumented, the flow rate can be captured on the real-time platform. So even if they are not instrumented, for some flow meters, transmitters can be retrofitted to them. So meaning that we can just bring in a transmitter, and if you have a flow totalizer that doesn't have a transmitter, then it can be replaced with one that does, and you pretty much can see the rates on the platform. Okay, so there is a question someone raised. That should be Kenneth Chuku, right? Okay, so Kenneth Chuku, just a second. Okay, Kenneth Chuku, we can unmute now and ask the question. Thank you.
Okay. Thank you, Lukman. Good morning. Thank you for a wonderful presentation. So my question is about this is digital oil field revolution. So my question goes around the quality of hydrocarbon. For instance, is there any tool now that can be used to measure the quality of crude in a sampling pot without having to come and get some samples and go and run the test in the labs?
Okay, so when you say quality, do you mean in terms of
Water
the
cut.
gravity? Okay, water cut? Well, the thing is, so it's a function of the device itself, right? If there's a device available for analyzing the quality of the crude in real time, and the result can be transmitted, then we can have the result on the platform, right? But in terms of devices, we the devices that we deploy are mostly sensors, pressure, temperature, and flow meters, right? So, but those devices for sampling, it's not really what we do yet. But if you have any device at all, whether it's a sampler that analyzes and the data can be transmitted, then we can get it into the platform and it can be viewed and analyzed in real time.
Okay, my question was, do you have an idea of any device that can do this?
No, I don't.
Okay.
Thank you.
Thanks.
Okay, so okay, please, once the feedback comes on your screen, just it should be on your screen. Just please just fill it, and let's have your recommendations, and your feedback would really be appreciated. So we still have about 15 minutes for the scheduled time. So if we have more questions, please keep them coming. If you can also chat as well, Okay, let me see. I think there are a few questions on the chat. Yeah, we can take this question about cost offline, and maybe we can contact you later. Then there is are these solutions migrated to cloud service? Yeah, there is an option for there are two options. One is on-premise, and it can also be cloud-based. So that is the IT architecture side of it. So it can be cloud-based. This solution migrated. Okay, yeah. So it can be cloud-based. Yeah. So I mean, it depends, because there is a question about, is it going to be effective without being cloud-based? So there are different reasons companies decide to host IT systems on premise. So it could be data security, or it could be the fact that they've already invested in the infrastructure, right? And it has to be used. So, or it could even be cost. So, but in any case, this system can be deployed either on premise or on the cloud. So it now depends on the effectiveness of each of the systems that the specific user is using, right? So it's a flexible option, is a flexible system that can be deployed either on premise or on the cloud. Yeah, so well, for this system, obviously if it's on premise, the advantages of probably having it on the cloud might be accessibility, right? So there's better accessibility. Cost-wise, it might be better. Then technology-wise, the cloud service providers, are also able to in terms of the technology, they are able to keep up with the pace of evolution of technology in terms of computing, right? So cost and technology and accessibility might be an advantage, might be advantages of having it on the cloud, right? So why having it on premise? There's the sense of security that comes with it, that is within your premises, right? So then if you have the infrastructure in place already, then that takes away the cost, the initial cost of deployment. So because you obviously have to pay subscription to any cloud service, and as your the amount of space and computation and needs increases, the subscription cost increases. So they have their advantages, but if you don't have any IT infrastructure on ground and most of your systems are already on cloud, then I would recommend you go with the cloud option. So do we have any other question? Yeah, please fill the feedback form. It takes about a minute. Kindly, would really appreciate it. Thank you. It's also in the chat panel, so you can just click on it and fill. So do we have any more questions? Okay, so we'll just give like a couple of minutes for you to fill the feedback form. And if there are no other, is there still a question from Kenneth Chuku? Because I see your hand is still raised.
Sorry, no question. It was the previous one. Thank you.
Oh, okay. Okay, thank you. Okay, so please kindly fill the feedback forms. We'd like to know what topics you would want to see us present in this series. Your feeling about the digital oil system, what you think can be improved, or even if you have questions that you'd want to follow up with later. So please just assist with filling the feedback form. I really appreciate it. It's the feedback form is on the chat panel. So okay, so I would like to thank everyone for at least taking the time to join us. This is a series we do every quarter, covering different technologies or different aspects of our services. So we'll be having the next one next quarter, towards maybe the middle of next quarter, maybe May or so. So it's going to be on a different aspect of our service as well. So we look forward to having you, and we also look forward to keeping the discussion going. You can send us emails. You can send us comments. So if you have any of our systems or you need any support, we'll be happy to provide that. So we want to use this opportunity again to thank you once again for joining us, and we look forward to having you again join us in May for our next webinar session. Thank you, everyone. Thank you. All right. Thank you. Have a great day, everyone. So we'll be ending the session now. Thanks.